Hello, and welcome to a video presentation on fractions and decimals. Here's what you'll learn: how to identify rational numbers and place them on a number line. Fractions are portions of a whole. For example, if you have a pie cut into 8 slices like this, and you ate one piece of this pie, that means you ate 1/8 of the pie. 1/8 is a fraction and can be written as 1/8. Fractions are also division problems. So we can express fractions as decimals by dividing the numerator by the denominator. We can express 1/8 as a decimal by dividing 1 by 8. Let's go ahead and do that with long division. Now 8 does not go evenly into 1, so we'll put a 0 in our answer above the 1, and we want to keep dividing. So we'll put a decimal after the 1 and a decimal after the 0 in our answer, and we'll add a 0 after the 1. Now 8 goes into 10 how many times? One time. 8 times 1 is 8. So we'll subtract 8 from 10 and get a remainder of 2. Let's keep dividing by adding another 0 after the 1. Bring that 0 down to our remainder of 2 to make it 20. Now how many times does 8 go into 20? 2 times. 8 times 2 is 16, so let's subtract that from 20 and get a remainder of 4. Let's keep dividing. Add another 0 after the 1. Bring that 0 down to our remainder of 4 to turn it into 40. Now how many times does 8 go into 40? 5 times. In fact, 8 times 5 is exactly 40, so we get a remainder of 0 and we're done dividing. That means our fraction 1/8 is the same as the decimal value 0.125. Now fractions can be located on a number line. Since fractions are parts of a whole, they are located between integers on a number line. Consider the number line below showing 0 on the left and 1 on the right. If we cut this section of our number line into 8 equal pieces like we did with our pie, the number line would look like this. If none of our pie has been eaten, that would correspond to 0 out of 8 pieces gone. So 0 as a fraction is 0/8. If one piece of our pie has been eaten, that would correspond to 1 out of 8 pieces gone. And so forth down our number line until all 8 pieces of the whole pie has been eaten. 8 out of 8 pieces. Now, some of these fractions can be written another way. Some of them can be reduced to simpler form. For example, 4 out of 8 pieces is the same as 1/2 of the pie. 2 out of 8 pieces is the same as 1/4 of the pie. And 6 out of 8 pieces is the same as 3/4 of the pie. The fraction 1/2 is 1 divided by 2. And if we divide 1 by 2, we get the decimal 0.5. The fraction 1/4 is 1 divided by 4, and that would give us 0.25 as a decimal. The fraction 3/4 is 3 divided by 4, which is 0.75. And dividing the rest of the fractions yields the following decimal values. We already did 1 divided by 8, so we know that's 0.125. 3 divided by 8 gives us 0.375. 5 divided by 8 gives us 0.625, and 7/8 is 0.875. Now, what are rational numbers? Well, rational numbers are numbers that can be written as fractions. Is 6 a rational number? Think about it. Can 6 be written as a fraction? Absolutely it can. We can take 6 and put it over 1. 6 divided by 1 is 6. So since 6 divided by 1 is 6, this proves that 6 is a rational number. Prove that negative 12 is a rational number. Well, negative 12 can be written as negative 12 over 1, or negative 12 divided by 1. Since negative 12 divided by 1 is 12, this proves that negative 12 is a rational number. We could express it as a fraction. Now remember, rational numbers are numbers that can be written as fractions. How about this decimal number? Is 0.75 a rational number? Well, can it be expressed as a fraction? If 0.75 can be written as a fraction, then it's a rational number, and it can be. We can turn decimals into fractions by writing the numbers without the decimal in the numerator of a fraction. Here's how we do that. Take a look at 0.75 above. If we pulled the decimal out, we would have the number 0.75 or 75. Put that in the numerator of a fraction. Now, what goes in the denominator? Determine the place value of the digit farthest to the right. The number farthest to the right in 0.75 is the 5. In this case, the 5 is in the hundredths place. We write that value in the denominator of the fraction, hundredths. So 75 over 100 is the fraction form of the decimal 0.75. Since we could express 0.75 as a fraction, it is a rational number. Prove that negative 13.6 is a rational number. Well, can negative 13.6 be written as a fraction? You know it can. We can turn decimals into fractions by writing the numbers without the decimal in the numerator of a fraction. So take a look at negative 13.6 above. Pull the decimal out and everything else goes in the numerator. So we put negative 136 in the numerator of a fraction. Then determine the place value of the digit farthest to the right. The digit farthest to the right is the 6. In this case, the 6 is in the tenths place. So write that value in the denominator of the fraction. Negative 136 divided by 10 is the fraction form of the decimal negative 13.6. Since we can express negative 13.6 as a fraction, it is a rational number. Now, let's graph some rational numbers on number lines. Let's graph 2.5 on a number line. 2.5, or 2.5, is located halfway between 2 and 3. Place a dot midway between 2 and 3 on the number line. And you're done. Let's graph negative 3.1 on a number line. Negative 3.1 is located between negative 3 and negative 4. In fact, it's only 1/10 of the way past negative 3 on the way to negative 4. So we're going to place our dot just a little bit past negative 3. Put it right there. That is negative 3.1. Now let's do a word problem. High tide in Astoria, Oregon on July 1st was at 11:31 a.m. The graph shows how much earlier or later in minutes that high tide occurred in nearby towns. First of all, let's use a fraction to estimate how much later in minutes high tide occurred in Vancouver. Well, the first thing we have to do is find the bar corresponding to Vancouver, and that's the purple bar. So, from the top of the bar, move straight over to the left, and we'll read the value off of the y-axis. In fraction form, high tide occurred 5 3/4 minutes later in Vancouver. Now use a decimal to estimate how much earlier in minutes high tide occurred in Charleston. First, find the bar for Charleston. That's the red bar. Now from the bottom of that bar, move straight over to the left and read the value off of the y-axis. It's just a little bit below negative 1 on the way to negative 2. So we'll read that as 1 1/4 or 1.25 minutes earlier. Or you could write negative 1.25 minutes. the negative sign would mean the word earlier, or before high tide in Astoria. Finally, what are irrational numbers? We've been talking about rational numbers. What are irrational numbers? Well, irrational numbers are all the other numbers that cannot be written as fractions. While rational numbers can be written as a fraction and have decimal equivalents that terminate, or decimals that don't terminate but repeat in a pattern, irrational numbers never terminate and they have no identifiable pattern. Examples of irrational numbers include pi, e, which is Euler's number, and the square root of any non-perfect square, such as the square root of 2 or 5 or the square root of 13. Taken together, rational numbers and irrational numbers make up our real number system. Congratulations! You've learned how to identify rational numbers and place them on a number line.